What we're going to look at now is how to solve a trig equation. We're going to start with two pretty basic ones. First of all, sine of theta equals a half. To be solved for theta being between 0 and 360 degrees. Now, you've come across work like this before at GCSE, sine of theta equals a half. And your natural inclination, I hope, will be to take the inverse sine of both sides, reach for the calculator, make sure it's in degree mode, and inverse sine of a half is 30 degrees. You actually know that already from your exact trig values. The problem with this answer is that whilst it's good as far as it goes, it isn't the full answer. We need to consider all the possibilities between 0 and 360 degrees. And to do that, it's absolutely critical that we sketch the graph of the function. And so you need to get used to producing a good quality sketch. You don't want to take ages drawing this. That wouldn't be a good use of your time. But you need to be able to see the 90 degree mark, the 180, 270 and 360 degree markers. You need to recognise that y equals sine of x or y equals sine of theta has a maximum value of 1 and a minimum value of -1. And you need to know the basic shape of the curve. That's y equals sine theta. Now, what the calculator has done for us when it did the inverse sine of a half is it has judged for us that there is a value of x, or theta rather, here, which corresponds to a y value of a half. The calculator is great at working things out between 0 and 90, -90 and 90, that sort of range, depending which trig function you're using. But sine of theta equals a half also contains a solution just here. And your calculator cannot work this out. You need to do it. And the best way to do it, I think, is to just look at the symmetry of the graph. You can judge that 0 to 30 must be the same as something up to 180. Or if you prefer, you can look at the symmetry that exists through 90 degrees. But one way or another, you need to judge that this will be 150 degrees. And so from the graph, we get our second solution. At that point, it's worthwhile taking a calculator and trying sine of 150, because if it's right, then it will also give you a half. We know that there are no other solutions between 0 and 360 because there are no other intersections on the sketch. Let's look at a second example. Let's try cos of theta equals -3/4. Well, inverse cos of both sides, and the calculator tells me that theta equals 138.6 degrees if I round it for the time being to one decimal place. But again, we can't stop there. We need to sketch the graph of y equals cos x. To do that, you obviously need to know what it looks like. And as before, you want a decent sketch that doesn't take too long to produce. The better your sketch, the more helpful it will be. Now, cos of theta equals -3/4. There's your -3/4 there. And we can see that we're expecting two solutions. There's one there and there's one there. Now this is the 180 degree mark here. So this must be the 138.6 degree solution that the calculator found for us. In here there is a gap up to 180 degrees. And that gap will be matched perfectly by that gap because of the symmetry of the graph. Now that gap is 41.4 degrees. So if I add 41.4 degrees onto 180, then it should get me to here. 180 plus 41.4 is 221.4. And if I work out on my calculator cos of 221.4, it should make almost but not exactly -3/4. And it does. The reason it's not exact is because I rounded my original answer. The last example I want to look at in this video is if you're dealing with tan. Suppose we have tan of theta equaling 2 between, let's say, between -180 degrees and positive 180 degrees. Theta equals inverse tan of 2. The calculator tells me that that is 63.4 degrees. And again, that probably isn't the only answer. We need to draw a sketch to see if there's something else we need to think about. So, this time, the tan graph is quite different to the sine or cosine graphs. The best way to remember it is to memorize this shape, to remember that it cycles between -90 and positive 90. So this is -90. Excuse me. -90 and positive 90. And at these values, we have what is called an asymptote. And then the curve cycles again in the next 180 degrees. And so we're going to get a curve that does that, and a curve that does that. This will be at 270 degrees. This will be at -270 degrees. Now, tan of theta equals 2. We haven't got a scale on the vertical axis. That's because it goes up forever and also down forever. But we can still pick something reasonably sensible. Let's draw this in green. Tan of theta equals 2 is perhaps about there. And we can see that there are solutions to this equation in those three positions. This one is the one that we've found. This is the 63.4 degree solution here. There's another one here, but this is out beyond 180. 180 is there. This one is outside the range that we were asked to deal with. This one, however, is inside the range, so we need to look at this more carefully. There's the negative 180. This is inside the appropriate range. Now, the nice thing about this is the graph cycles every 180 degrees. So all we have to do is take the 63.4 that we worked out, and we can add or subtract multiples of 180 to that. We want to go to the left, so I'm subtracting 63.4, take 180, makes negative 116.6 degrees. And if I do tan of that angle, it should make pretty much 2, and it does. Again, not quite perfect because of the rounding that we performed at the first stage. So you find the first value with your calculator and you use a good sketch of the graph to find any other values in the range that you've been told to use.